Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, students. How are you today? Well, I'm fine too, thank you. Well, okay, before we start our lesson today, it will be a great thing if we start with praying together. So, pray begin. Finished. Okay, thank you. Next, let me check your attendance first. Actually, I prefer to call you one by one, but I think that we waste so much of time. So, this English attendance today. Come on. Is there anyone absent today? No. Um, so everyone's here. Okay, thank you. Oh, wait, let me check first. Okay, good. So everyone's here today. Thank you. It means that you are ready to learn physics. Are you ready for today? Are you ready? Yes, I'm ready. Okay, so that's good. Thank you. So students, actually a lot of things, a lot of simple activity could be explained by physics, by science. For example, have you ever played guitar instrument? You cannot play guitar, but you know how to do it, right? We play guitar by plucking the guitar string. When we pluck the guitar string will be vibrated up and down, and then the harmony or melody could be heard by our ears. Another example is when you throw a rock into a calm water, and then the water will create such a pattern. And by those two examples, we already witnessed two of the physics phenomena. It is what we call as wave. Yeah. So actually last meeting we already so actually last meeting we already learned more about wave, start from its definition, and then the characteristic, the properties, and up until to the categories. And for today's material, we only discuss the kinds of wave based on the needs of the medium to propagate. So wave is classified based on the needs of the medium into two kinds. There are mechanical wave and electromagnetic wave. So is there anyone knows what the difference between those two waves? Anyone wants to volunteer? Someone? Which one is the wave that needs a medium and which one is not? Vicky, please. Yes. Okay, that's correct, Vicky. Give applause to Vicky. Well, that's right, yeah, students. So, those two wave is the categories of wave based on the needs of the media. And the one that we will talk about and discuss more is the mechanical wave. Mechanical wave. And mechanical wave could also be classified based on its amplitude. So based on its amplitude, mechanical wave is divided into two categories. But before that, are you remember about amplitude? Do you remember about amplitude? No? You forget, okay? Please read more in your textbook, okay? So amplitude is the maximum extent of a vibration that measured from the position of the equilibrium. So based on its amplitude, mechanical wave could be classified into one, traveling wave, and the next one, the second one, is standing wave. Standing wave could also hold as stationary wave. And what is the differences between these two kinds? We will explore more about these two. But before that, let me convey today's learning objective. So by our learning activities, you guys, students, should be able to first mention the daily events that involve the phenomenon of traveling and standing wave. The second one is you should be able to differentiate the concept of the standing wave. And the last one is you should be able to demonstrate a simple experiment from the traveling or the standing wave and make a report from our activities. That's for our learning objective today. So let's just start. The first one is traveling wave. Traveling wave. So traveling wave, based on its definition and based on its amplitude, is the wave that has the same amplitude and phase, amplitude and phase at every point in its path. So this is the definition of traveling wave. And if you pay attention at this, you should be highlighted this word, same amplitude at every point. So this is the highlighted one. So wave has its own path and it's in every point. Traveling wave has the same amplitude and phase. Let me show you the clear version or the simulation of traveling wave. Okay, so this is the simulation of the types of mechanical wave, especially in traveling wave. You could see on the television here. This is the simulation of traveling wave. You could see that the wave is seems like to be walking, to be moving to the right? Like it's traveling. So when the wave is propagates, it always have the same amplitude. It has always the same number of amplitude. Look at this. It looks like that it's moving to the right. And it could also we could change the direction. And when we change the direction to the left, look, it will moving or walking or traveling from right to the left. And in this simulation, you could see the traveling wave in transverse wave and in longitudinal wave. Okay, this is what we call as traveling wave. And traveling wave, like some other kinds of wave, has its own parameters and equation. So the parameter of traveling wave, there are some of them. The first one is frequency. Frequency is the number of wave vibrated that undergoes in 1 second. So do one of you knows the formula of the frequency? Is there anyone knows? So pay attention to the definition. The definition of frequency is the number of the wave that created in 1 second. So the formula could be written as F. F is the symbol of the frequency. So F equals to N divided by T. N is the number of the wave that created here, and T is the travel time. Okay, so remember that this is the frequency formula. Next one is period. Period is the opposite of the frequency. Since the frequency is the number of the wave that created in 1 second, period is the time that needs to do one oscillation. So since period is the opposite, T, capital T or period, is equal to inversely proportional to the frequency. And since frequency is N divided by T, we could write T, capital T or period as T divided by N. Okay, so this is the period. And the next parameter is wavelength. Wavelength is usually symbolized with lambda. Yes, like this. Lambda or wavelength is the distance of vibration that travel. So wavelength, the formula of wavelength, wavelength is lambda equals to L per N. So this is the distance, and L is the distance of the vibration, and N is the wave that created, the number of the wave that created. And one wave consists of one crest and one valley or trough. So this is the position of the equilibrium, and this is the crest, and this is trough. Remember that this is one wave, one trough and one crest. Another way to say it is this is node and this is the antinode. So there are 2 antinodes and 3 nodes for one wave. This is one wave. And the last one, the last parameters of the traveling wave is the wave propagation velocity. Propagation velocity. That we symbol it with V, small v. And V symbol with, equals to lambda times F. Here, pay attention to here. F is inversely proportional to the T. So F will be written as, V will be written as lambda divided by T. So these are the parameters of the traveling wave. And traveling wave has its general, equation that could be written as yp equals with by a sin omega t plus minus kx, where yp is the deviation or the displacement from of a point P, and then A is the amplitude, and then omega, it's omega. Omega is the angular velocity, which is proportional to the 2pf and f, and then, or we could say it as 2p divided by t times t. T is the time, and then k is the wave number. Wave number is equals to 2p divided by lambda, and x is the distance. Look at this equation. It has plus value or minus value. We use the minus value if the wave propagates from the right to the left. So like we see here in our simulation, if the wave comes to the right, from the right to the left, it means that the wave propagates to the left, and it means that it has a minus value. But if the wave moving from the left to the right, it means that the wave propagates to the right. It should be right. It should have the plus value. That's it. So that's how you differentiate different. Oh, what is it? Sorry. Differentiate the plus minus value. Okay, that's all for the traveling wave. Next, for the standing wave, I have something to show you. Do you know this thing? Yeah, this is an elastic rope that made from rubber rope. So by rubber rope, you could create or make a long elastic rope like this. Well, in my old days, we always play some traditional games such as yeye. I don't know how you call the game, but I call it as yeye. And then, or just skipping rope, you know, the skipping sport, like that, and other things. So by doing this, by doing skipping sport and then yeye, actually we already witnessed the phenomenon of the standing wave. And why does it called a standing wave? So by answering that question, I need a volunteer to do a simple demonstration with me. Anyone wants to do it? Please come forward. Putri? Please come here. And I hold the other one. And what you need to do next is give an action to the rope. So here I'm gonna give an action to this. So it will come like this. Look at this. It prompts a pattern. And next, I will giving a bigger frequency, and let's see. Look at this. It forms a pattern, right, of wave, and this is what we call standing wave. Okay, Putri, thank you. That's how you do a demonstration or experiment with this elastic rope. And I will show you the clear version of this experiment. Look at the television. Okay. So this is the the standing wave. Look at this. Here you could see that harmonics, a low frequencies. So if I give the right frequencies, the elastic rope will be vibrating. So it has first harmonic. Okay. So this is the first one, the first activity that we do. It is too slow, I think. Yeah. But it doesn't matter. Yeah. If you observe what I did before we put it, the first activity that we do is just like this. It form one pattern like this. So if we write here, if I draw the pattern, it will become like this. This is the position of the equilibrium. And it will be like this, right? And the second activity, give the bigger frequencies, the bigger frequency, so it will become like this. Look at them. They have two crests and two truth, or two notes, two antinodes and three notes. Let me draw here. Okay. Good. So you look at this. It has two antinodes and three antinodes. Three notes and two antinodes. While the first one, or we call it as first harmonic, only has one antinode and two notes. This point, and this point, we also call it as constructive. And this one, like this is destructive. So what is standing wave? What is standing wave? Anyone want to guess it? Why it called as standing wave? Anyone? So actually, standing wave, like what just we observed here, is marked by points that appear to be standing still. If you look carefully, it doesn't moving to the right or to the left like traveling wave, right? It's only stay there. What change is the amplitude. The amplitude is changed over time, like up and down, but it doesn't move. So that's why it's called standing wave. Standing wave created because there is the incoming wave here are reflected back, and then the interferences occur. The interferences that created is constructive and destructive. And the first one is what we call is first harmonic. And then the second, this is when there are two crests created or two constructive created, we call it as second harmonic. And if we draw again, we will get the second, it's too ugly. We will get the third harmonic. the clear version is in the simulation. We could see that there are 3 constructive that created. And this is the third harmonic. Okay. Please pay attention to the first harmonic. You know that from this point to this point is the length of the rope for the elastic rope, or the distance. So from this to this, let's symbol it with L. L is the length of the point here to here. And look at the wave that created. Wave created. What, how many the number that of the wave that created? Anyone knows? Yes, that's right. If we continue to draw, then it looks like this, right? So from like before, I just explained in traveling wave, one wave is one crest and one trough. So because it's only one trough that created, then it means that the wavelength is only a half of lambda. So L is equals to a half of lambda. Oh, sorry. Sorry guys, I'm not focused. Okay, so half of lambda here. So next is, let us find the frequency of the first harmonic. What is the frequency formula? F is N. Yes, that's right. Frequency is N per T. But if we, what is it? In velocity, in wave propagation velocity. Do you remember? V is lambda times F. So F is V divided by lambda. This is what we call as another formula frequency, right? And for the first harmonic, F, we symbol it as F1, yeah, and then V divided by lambda 1. Here in the first harmonic, L is equal to a half of lambda. So here is lambda 1. So lambda 1 is equals to 2 times L, 2L. So let's substitute this lambda to this equation. Then we get F1, or the frequency of the first harmonic, is B divided 2L. So we could use this formula to find the frequency of the second harmonic and third harmonic. So F2 and F3. Please, maybe a volunteer wants to write down here. Anyone wants to do it? Amalia? Okay, please come here. First, you need to find the wave of the number of the wave first, and then lambda, find the lambda 2, and then you could substitute the equation to frequency equation. Yeah, okay, thank you. Do you want to continue or another one? Wahid, pay attention, please. Come over here. Be careful. Please. Find the number of the wave first. How many wave that created? How many the numbers of wave they created first? Yeah. Okay. Okay, thank you. Students, pay attention to what Wahid writes. Is Wahid right? Is this equation right? Anyone wants to correct it? I think it's not correct yet. Anyone's one? It has something. What is it? It's not correct yet. Anyone want to volunteer? Vicky?